Good morning, everyone, and welcome to today's webinar, Which Engineering Program is Right for You? My name is Daniela Cross. My pronouns are she and her, and I am the Associate Director of Marketing and Recruitment for the Faculty of Engineering at the University of Waterloo. Before we get started, just a few housekeeping items. Closed captioning is available through Zoom. You just need to click the CC button that's at the bottom of your screen. If you can't see it, click the More button with the 3 dots, and then you can enable the live transcript with the CC button. If you have questions today, please submit them using the Q&A button at the bottom of your screen. The questions will be answered through typed responses by staff and students, and as many questions as possible will also be answered out loud during the Q&A portion of the event. If you have additional questions or really specific questions, we encourage you to email enginfo@uwaterloo.ca with any additional questions you have. I'd like to start us off with our territorial acknowledgement. The University of Waterloo acknowledges that much of our work takes place on the traditional territory of the Neutral, Anishinaabe, and Haudenosaunee peoples. Our main campus is situated on the Haldeman Tract, the land promised to the Six Nations that includes 6 miles on each side of the Grand River. Our active work toward reconciliation takes place across our campuses through research, learning, teaching, and community building, and is centralized within our Indigenous Initiatives Office. And if you're interested in learning more about the land that you occupy, you can always visit this website that's called nativeland.ca to find out more. All right, so today we're going to cover off a number of programs that we have within the Faculty of Engineering. We have expert panelists here with us to tell you more about each of our 15 direct entry undergraduate programs. So we will go ahead and get started. We're going to be covering all of these programs today. And as I said, if you have questions, type them into the Q&A using the Q&A button, and we will answer those questions throughout the event and then during the live panel at the end. So we'll start off with our School of Architecture.
Hi folks, my name is Nicole Gunther. My pronouns are she and her, and I am the program coordinator for the Bachelor of Architectural Studies program. The Bachelor of Architectural Studies pre-professional degree is step 1 to becoming a professional architect. So it is important to make the distinction now that this is an architecture degree, not an engineering degree, and it will set you on the career path to becoming a professional architect. The framework for our program is design, which takes place in studio. Our students are designing from day 1. In their very first term, they are participating in design studio 2 full days per week. Many of the students that excel in our program and are drawn to our program are those that excel and enjoy STEM courses as well as art courses. To dive a little bit more into the program, first year begins with designing smaller spaces like residences and galleries. But as the curriculum builds in complexity in size and scale over the subsequent 5 years, students design high-rise urban buildings, cultural projects, and landscape projects. In the final term, all of the knowledge gained over the preceding years culminates into a comprehensive building design studio. At this point, students are designing from the ground up. This includes foundation siting, building envelope, and structure programming. The result of the intense curriculum, coupled with the up to 24 months of co-op experience, allows students to work in architecture firms immediately following the completion of their degrees. The program also features 4 streams that broaden student experience and all feedback into the design pillar of the program. These streams enrich the design studio experience and knowledge gained by students. The streams are technology and environment, visual and digital media, urbanism and landscape, and cultural history. And again, these 4 thematic areas enrich and tie back into the fundamental pillar of the program, which is design studio. The architecture program also has a very strong international focus. Many of our students travel abroad for their co-op terms, participate in international academic exchanges, and in 4th year, the entire class travels to Rome, Italy at our 2nd permanent campus for a semester of learning abroad. Thank you so much for listening. I look forward to answering any questions that you have after the presentation.
Thank you so much, Nicole. We're now going to cover off the Department of Chemical Engineering and the Nanotechnology Engineering program.
Hi, good morning, everybody. I'm Adnan Fakouri. I'm a third-year nanotechnology engineering student, currently completing my 3B term, and I'm happy to be presenting the chemical and nanotechnology engineering programs to you. So to start off, we'll take a look at chemical engineering, and this program takes the basics and fundamentals of science, physics, chemistry, mathematics, and economics, and applies that in order to transform raw materials that we can extract into useful materials and final products that are used by industries and people. The program sets out to solve a wide range of problems that revolve around either society or the industries in which chemical engineering is concerned with, and the name of the game is to do this in a safe, economical, and environmentally friendly way in order to ensure that our processes are sustainable, cost effective, as well as safe in terms of exposure. And the next point is conceiving and designing processes which are used to produce, transform, and transport materials and energy. So they take for example, some raw materials in a current state, and then they would refine that in order to make a final product or an intermediate product that can then be used further on by businesses or people in order to complete final processes. So the reason why chemical engineering is a major player in today's economy is because there are a lot of global problems that require this field of study in order to be solved. One of the most relevant ones today is in the field of human health and medicine. Chemical engineers usually go into the medical field where they are concerned with mass production of normal drugs as well as vaccines, and also sustainable agriculture, which is to make sure that food and water quality and quantity are preserved and making sure everybody gets an equal opportunity in terms of the accessibility to food as well as the access to clean water. Another major point is in climate change and as well as sustainability. And this is making sure that the processes that we use as chemical engineers are controlled in terms of emissions. And there are a lot of courses that go through the ethics of this, as well as to monitor pollutions and pollution monitoring systems, which is a large part in chemical engineering because some of these processes do emit. So it is important to make sure that there are strict measures in place to keep everything sustainable, as well as move us in the right direction in terms of climate change and work on the research in renewable energy to make sure that we lose dependence on fossil fuels and non-renewables very soon. The next slides here are about nanotechnology engineering, which is my field of study. And in this program, we use a lot of different fundamentals and concepts from many different fields of science. In our first and second year, the main goal of the courses is to build a very strong foundation in material science, quantum mechanics, organic chemistry, regular chemistry, thermodynamics. So we use a lot of the basics and fundamentals from these courses in order to build, produce, and design systems in the nanoscale. And the nanoscale is just anything measured in the nanometer, so which is 10 to the minus 9 meters, which you could all imagine is pretty small. And the only way we can actually see these systems and interact with them is via the use of advanced microscopy, which is a topic in at least 2 courses that I've taken so far, that we go about how do we actually measure these systems and make sure that our results are quantifiable. Now, this program at the University of Waterloo is the first accredited undergraduate program in Canada with the main focus on nanotechnology. And it has so far remained one of the best options in terms of that, because as soon as you enter the program, you are put into the groove of thinking of everything in the nanoscale, as well as trying to change conceptual understanding on what the bounds of engineering are and sort of challenge these bounds and say that if something was at first thought to be too difficult or not possible in terms of our technology, then we might be able to develop something that could help change that. And our facility at the University of Waterloo, the Michael Lizardius Quantum Nano Center, has one of the most advanced fabrication rooms in Canada. So as soon as you would enter that building, you would see it. It's pretty cool. And it's the only undergraduate program where we're allowed to go into clean rooms for fabrications. And the clean room is basically where we make capacitors. Students basically learn to design, model, and fabricate and characterize microscopic structures, which are those nanostructures, and that are used by a wide range of industries. So it's not very limited. A lot of different industries have now started new operations in terms of research and development to make sure that they're getting the best use out of their materials, and also by designing everything as efficiently as possible. And a lot of the professors in our program are highly experienced in terms of research and industry. So what they bring to the class is their everyday experiences. Our professors are always talking about how they had a research project that they're working on. And they also are actually a big employer in terms of students to go to work with, because they have very interesting projects and they often take on undergraduate students. So if that's something you're interested in, then that's also an option to be able to stay within the university environment and work alongside one of your professors. But also they also have great connections in the industry, because as I said, in the industry now, most companies are looking for new ways to innovate and to use their materials efficiently and to make sure all processes are running as advanced as possible. So that's another big field for nanotechnology engineers, is in industry as well as research. Thank you very much for listening to my talk, and I'll be happy to answer any Q&A questions you guys have.
Wonderful. Thank you so much, Adnan. We appreciate that. We're now going to cover off the Department of Civil and Environmental Engineering. And we'll start off with David from our Architectural Engineering program.
Hi guys, I'm David, and I am currently in the second year or second co-op and moving on to 2A for the Architectural Engineering. To start off, I'd like to introduce my program, Architectural Engineering. So for the Architectural Engineering, we design new buildings and retrofit existing buildings with a focus on utility, sustainability, and energy efficiency. And sometimes we're also called the building engineers, because we're basically building a bunch of constructions, you know. Students in this program will learn about the applications of the new building materials and technologies, and as well as we will have the design studio each study term, and are taught by the architects and engineers. And most interestingly, for the third year, we'll be going to Cambridge for the School of Architecture, and it's going to be a fun term there. For the optional degrees, credentials, we have building structures and building systems specialization. And moving on to civil engineering, which is the other type of the engineering. So yeah, this type of engineering is pretty similar to the architectural, and it is very important for today's urban centers. Students in civil engineering program learn how to design and build the structures and systems that stand for the test of time, including highways and airports, bridges and skyscrapers, and the municipal infrastructure. And the courses cover everything from mechanics and stress strain to public safety and hydrology, which is pretty similar to architectural engineering. And there are 4 optional degree credentials, which are geotechnical, structural, transportation, and water resources specialization. Thank you for listening for me, and I'll be glad to answer any questions.
Hey, my name's Jason. I'm in geological engineering, currently in my 4A term. I'm going to talk to you a little bit about environmental and geological engineering. So a big part of environmental engineering is applying design principles of engineering to environmental problems. So this could be air quality engineering, or even remediating rivers, designing better rivers. Waterloo has a really strong background in water research, dating back to really the founding of the school. As such, there's lots of research opportunities, and there's many professors who teach a wide range of courses related to water and water treatment. In terms of careers, there's lots of environmental engineers that go on to work in consulting firms across Canada, as well as government agencies who work to protect the environment and enforce environmental regulations. There's sort of three different specializations you can take with environmental engineering. One of them is hydrology, another one is energy, and the third one is pollution treatment and control. So depending on your interests, you can sort of focus your electives in your upper years towards one of those specializations. For geological engineering, it involves more of a study of geological materials and any engineering behavior related to it. So that could be flow of water through it, building structures on it, or even just understanding why certain rock units or soils occur in certain regions and trying to predict that. A big part of geological engineering is being able to deal with uncertainty, because you can't see what's under the ground, and there's only so many holes you can drill or surveys you can do on the ground, because that costs money. So a big part of geological engineering is teaching you how to make proper engineering decisions based on limited knowledge and dealing with high levels of uncertainty. You'll also learn how to design structures such as retaining walls, slopes, even rivers. You'll see there's a lot of overlap in the next slide. And a lot of this work involves a lot of outdoors work. If you choose your courses right in third and fourth year, you can qualify as a professional engineer and professional geoscientist. And for graduate careers, geological engineers tend to work for a wide range of consulting companies, government bodies, as well as mining companies you can work for. So there's a pretty wide spectrum of career opportunities available. The three specializations available in geological engineering are geology, which is more of a focus on the earth science courses you can take, hydrogeology, and soils, rocks, and structures, which is more of a specialization into the civil aspect of geological engineering. And so here we can see a lot of that overlap that I sort of mentioned earlier. So between civil and geological engineering, geotechnical engineering is an area that both of those programs will cover. So as a geological engineer, all of our geotechnical engineering courses are pretty much taken with other either environmental or civil students. And even in some of the areas of the Venn diagram here that aren't overlapped, the theory and concepts are very similar to other programs, and you'll notice a large range of overlap. So just by choosing one program doesn't necessarily mean we can't do anything related to one of the other programs. Thank you for listening, and I'm happy to answer any questions at the end.
Awesome. Thank you so much. We are now going to cover off the Department of Electrical and Computer Engineering, as well as the software engineering program. So I'll turn things over to Edmund.
Hi everyone, my name is Edmund and I'm currently a computer engineering student here at University of Waterloo, going into 2A. So I'll start off with computer engineering first. So Waterloo actually has the most technical electives than any other computer engineering program in Canada. And so this allows students to really explore a whole variety of interests. And this includes things like circuit boards all the way to software security. Students will learn to design hardware and software systems, and you really start to understand how these two systems interact, how they impact users, and how they perform in real world settings. And during co-op placements, because we have so many different interests and topics, students will get to work on a whole variety of different tasks and projects. And this may include things like developing better search engines, designing hardware systems, creating artificial intelligence software, programming mobile devices, and analyzing system security. All right, moving on to electrical engineering. Electrical engineering students will study devices and systems that rely upon electrical energy. Students will learn to design more efficient, reliable technologies like wind turbines, global positioning systems, hybrid cars, communication systems, robotics, and other circuits and systems. Waterloo has one of the largest power energy research groups in North America. And so this allows students to really become experts in really interesting technologies. For example, photovoltaic panels, wind turbines, and smart grids. And just in general, electrical engineering students will learn a whole lot about electrical systems, the communication systems, control systems, and computer systems. Software engineering. So software engineering, unlike the other two, focus more on the software of computers, while the other two focused on hardware and kind of the physical aspect of them. So software engineers revolutionized computer software, making it usable, affordable, efficient, and easy to maintain. This program is jointly offered by engineering and computer science. And so this allows students to really benefit from access to both professors and courses that are offered by engineering and computer science. Previous to computer engineering and electrical engineering, you only get access to engineering professors and courses. So students will learn to analyze software architectures, apply algorithms, design human or computer interfaces, and optimize software for modern hardware. And in the industry, software engineering, it's really relying on teamwork. There's a lot of group work in software engineering. And so because of that, it's a really core part of the curriculum, and you can expect a lot of group work. Not a lot, but there is a decent amount. So a very common question that we get asked is, what is the difference between computer science, software engineering, and computer engineering? And so I'll start off with the program overview, just what you'll be learning. I'll start off with computer science. So computer science, you really focus more on software side of computers, right? The study of software, algorithms, programming, and the limits of computation. I'll move on to computer engineering next. So this program focuses on design and development of computing devices and systems. So compared to computer science and software engineering, you really focus more on the hardware and the physical aspect of computers. There still is software, but not as much. And so software engineering is kind of a mix between the two. This program combines computer science and engineering principles and practices to design, create, and maintain computer software to solve engineering problems. So you'll really have courses from both computer science and computer engineering, although it is still mostly software focused. You will earn a different degree for each program. For professional accreditation, computer science, you will get the computer science accreditation. For computer engineering, you get Canadian Engineering Accreditation Board. And so for software engineering, you will get both, as it's kind of a mix, right? For programming, prior programming experience, it is recommended for computer science and computer engineering, but it is actually required for software engineering. For the key program features, you'll notice here that software engineering and computer engineering are very, very similar in how the program is structured. Really, the main difference is that software engineering also has access to elective courses related to computer programming from CS and engineering. Meanwhile, in computer engineering, you only have access to engineering only. And so other than that, you both have a fixed course load, a fixed course schedule. A lot of the courses will be unrelated to computer programming and software development, and both only offer a 5-year program with co-op. On the other hand, computer science, you have a flexible course load, and because you have a flexible course load, you also will have a flexible course schedule. You will be guaranteed access to all elective courses related to computer programming from computer science, and a lot of the courses will be related to computer programming. And computer science also will be offered in both a traditional 4-year program and also a 5-year program with co-op. For potential careers, you'll notice here that computer science and software engineering, there's a lot of software and programming related jobs here, but with software engineering, people also tend to branch into things like staff engineer or project manager. Computer engineering, people also do become software developers, but a lot of people also tend to go to the more hardware side of jobs with hardware design engineer or things like a robotics engineer. So this is a really nice Venn diagram that really shows the similarities and differences between these 3 programs. I won't go into too much detail because it's pretty simple to read, and but I will just go over it a little bit. You'll notice here that each program does have their own niches, their own focuses in what they learn. With computer engineering, for instance, learning more hardware and physical aspect of computers, as I said. But there is overlap between all three programs. And really, because there are electives, if you take one program, you can end up taking electives, choosing electives to really structure your program into looking similar, but not exactly the same, but similar to the other two programs. That's it from me. I'm happy to answer any questions at the end.
Excellent. Thank you so much, Edmund. We're now going to move over to the Department of Management Sciences, and I will turn things over to Ada Hurst.
Hi, everyone. My name is Ada Hurst. I'm a faculty member in Management Sciences, and the department offers the Management Engineering program. And I've been teaching courses in engineering design in this program for over 10 years now. And so it's my pleasure to tell you a little bit about management engineering. So you hear the word management engineering, and the program is very different from what most people likely imagine when they hear those words. Many people think it's a combination of business and engineering, or others might assume that it's a program that teaches you a bit of every other program so that then you can become an engineering manager. So these assumptions are generally incorrect. And so what I'd like to tell you about is what is actually management engineering. Management engineers improve the efficiency of businesses in a world that is increasingly digital and data-centric. And so what do I mean by that? Well, modern organizational operations are highly computerized, highly automated, and there's big quantities of data that's being generated and used like never before. So what management engineers do is they design and build management systems, or also called decision support systems. And these systems, they're capable of capturing, processing, using data to improve processes and decisions in industry. So the program, as you can probably already tell, is heavily data-driven, but it's also very human-centric. And the reason for that is because the users of these management systems or decision support systems are people and organizations. So there's obviously then a concern for how people think and how people behave. And that's something also that is taught in management engineering. So given the skill set required to achieve the above, management engineering is an interdisciplinary program that integrates and applies three main core areas. So the first is data analytics and operations research. So this is a lot of applied math and data science. The second big area is software and information systems. This is a lot of computer programming, but also things like human-computer interaction, search engines. And finally, perhaps to a bit of a lesser degree, the third area is organizational science. And basically, this is a psychology of people and organizations, and also economics. So these are the three main core areas that are integrated in order to design and build the management systems or decision support systems that I talked about. So like I said before, management engineering has been around now for over 10 years, and it's really shown to able to provide a truly excellent training, and that we found is very in high demand in industry. Our graduates work as analysts, consultants, technical product managers, data scientists, and software developers, and more. And the program has actually maintained a very high co-op and post-grad employment rate, even during the pandemic, which I think really showcases the resilience and broad applicability of the skills. And the skills are really in high demand and useful really in any industry. So we find our co-op students and our graduates able to work in any industry and to find meaningful employment from software and high tech to finance, supply chain and logistics, healthcare and manufacturing. So I hope that gives you a nice overview about the program. But I'll be happy to answer any questions later during the Q&A, but as well as offline through my email. And I'll put my email address just in the chat for any of those of you who want to message me offline. Thank you.
Thank you so much, Ada. That was fantastic. We'll now turn things over to Cliff Butcher from the Department of Mechanical and Mechatronics Engineering.
Hello, everyone. Yeah, Cliff Butcher. I'm a assistant professor, maybe 6 years now. That's my fast. And my area is in automotive lightweighting and crashworthiness. So a lot of automotive stuff at Waterloo. So to give an overview of mechanical engineering, there's the common question I'll cover here is the difference between mechanical and mechatronics. And the short answer is both. Both are good. And most of us have the same interest, just end up focusing a little bit on one. So mechanical engineering, we use our technical skills and our knowledge a bit more on the physical sciences, like manufacturing, mechanics, fluid mechanics, heat transfer, power generation, a bit more applied physics, so you're a bit more on the solid sciences, I guess you'd say. We build machines, everything that moves, right, has been done by a mechanical engineer. We're in every company. I think you can always use a mechanical engineer, even in chemical plants, oil and gas, nuclear, aerospace, a lot of aerospace mechanical overlap, green energy. Yeah, so you'll find mechanical engineers everywhere. So really like applied physics, like force analysis and things like that, definitely might be for you. So if we skip to the next one for mechatronics. So mechatronics, like I said, probably like most of the same things as mechanical, but you may find you're a little bit more interested in programming, like programming sensors, electronics, electromechanical systems, to electrify, make robots, autonomous vehicles. You're a bit more, interested in that area. So that's sort of how you can tell the difference, I think, in my experiences here. You find you're naturally drawn to one side or the other. So our mechatronics program has been around, geez, I should know this. I think it's close to, around 10 years now. We're the first in Canada. It's a great program. We have a huge lab space, and the mechatronics and mechanical students pretty much have a 100% employment rate. Even the pandemic, they weren't hit that hard. You always need a mechanical or mechatronics student around. And the last thing is you can always transfer back and forth. That might be a question, not between the program, but on your co-ops. Mechanical people can end up in mechatronics positions, and mechatronics can end up with mechanical co-ops, things like that. So you're not totally siloed. Okay, well, that's great.
Excellent. Thank you so much, Cliff. And Cliff will be available as well to answer questions during the Q&A. We're now going to cover off the Department of Systems Design Engineering, which encompasses the Systems Design Engineering program as well as Biomedical Engineering. So we'll start off with Biomedical Engineering.
Great. Thank you very much. My name is Andrew Scott, and I'm a faculty member in the Department of Systems Design Engineering, which has been pointed out houses both the biomedical and the Systems Design Engineering programs. And I've been in this department for around, just over 10 years. So I've really seen the genesis and the growth of this biomedical engineering program, which is a relatively new program here at the University of Waterloo. Biomedical engineering is an emerging field, and students learn to design, analyze, and build technology, for example, pacemakers, training equipment, assistive devices, and medical equipment. The courses teach a variety of concepts. So it's a multidisciplinary kind of program. So we have professors from systems and biomedical engineering, and we also have professors from biology, from chemical engineering, from mechanical engineering, for example, that all contribute to teaching our students. And the concepts cover biology, ranging from fundamentals, for example, there's an anatomy course, to healthcare. So for example, healthcare systems, so how hospitals, for example, things about how they function. They prepare graduates to design tools and systems that can be used by medical professionals. So for example, something to feed neonatals, for example, in the NICU is something that our students might look at. However, the program isn't designed to prepare students for medical school. So we just like to point that out in case people sort of would like to, are thinking about it sort of as a prelude to medical school. So if you're interested in medical school, it would be better to consider something like biomedical sciences as opposed to biomedical engineering. So this is a standard engineering program, where you can work toward becoming a professional engineer. So maybe we can go on to the systems one. Thank you. So systems design engineering, people always sort of often think of this as being computer systems, but actually when we talk about the word system, really what we mean is we look at things at a high level. So, so for example, if you're thinking about something like aviation or like aircraft, for example, as a mechanical engineer, you might sort of focus on the design of the structure or the combustion chamber or something like that. A systems design engineer might look more at the human interacting with the aircraft, for example. So the pilot, the interfaces, for example, that the pilot might use. They might look more at the design of the airport, for example, and trying to optimize the flow of people and of material. Or they might look at designing optimization of the functioning of the aircraft itself in terms of efficiency or something like that. So that's kind of what we mean when we say systems. We're sort of really looking at a big picture. And that's just sort of one example, but there are a whole bunch of different kinds of applications that people might look at. So for example, environmental systems, transportation systems, and something called intelligent systems, which really overlaps with trying to find patterns in data and artificial intelligence, remote sensing systems. These are all things that faculty members in our department look at and things that you would get exposure to through taking our courses. A real sort of interesting thing about the systems design engineering program is that there's a lot of different electives that students can take to fulfill their degree requirements. So students might often use this to get an option or some kind of a specialization, for example, so to sort of build knowledge in another kind of area. I think that's it. But again, people are also welcome to email me if they have any questions and they want to talk anymore. I know it's hard to decide what program is right for you.
Fantastic. Thank you so much, Andrea. I'm now going to cover off a little bit about engineering co-op. Co-op is part of all of our undergraduate programs, as you've heard. So I'll just cover a little bit, and if you have any questions, feel free to type those in the Q&A. So during co-op terms, students can explore different careers and employers. So it really gives you a chance to get that real world work experience. And by the time you're done, you'll have earned about 2 years of full-time work experience in your field of study that you can use on your resume when you're applying for jobs, which is fantastic. Successful completion of 5 of 6 co-op terms is required to graduate. So most co-op terms are 4 months in duration. There are some 8-stream programs though. We'll cover that off in a bit. The co-op ratings in Canada range from about $8,400 to $21,000 per co-op term. So it really depends on your program and the term that you're in. As you advance and get more senior, you will hopefully earn more money during your co-op term. And then over 1,500 students participate in international co-op placements during a typical year. So on the next slide, you can see that we do have co-op placements all over the world. And even during the pandemic, we were able to have students doing co-ops internationally. A lot of our international students who were in their own country were still completing their co-ops there or doing remote placements as well. And you can just see some interesting stats about co-op, a very high employment rate, over $117 million in earnings for our engineering students, the average there, and 8,539 co-op positions in 2020. So that's a lot of co-op roles for our undergrad student population. And then, as I mentioned, we have work streams, so study and work sequences. It allows our students to alternate between work and study terms, and they'll be applying for jobs while they're in classes. And most of the programs follow the standard stream 4 or 8-stream sequence. And you can just see kind of the difference there. 8-stream just means that you have 2 study terms back to back in your first sequence and then go into a work term. Stream 4 is a study term for 4 months and then a work term for 4 months, and so on. It alternates. And I just wanted to say our students are very supported in getting their first co-op jobs and getting their jobs throughout their time with us. So there is a process for students to get their co-op jobs. Students will take a fundamentals co-op course. They'll upload their resume and apply to jobs through a system that we have called Waterloo Works that's very easy to use. They'll attend interviews, whether those are in-person or virtual interviews. Students then get to rank potential employers and the employers get to rank them based on the interview. And then the students are matched to get their co-op job and then start their job. So it's a really, really great co-op program at Waterloo. There's lots of support with reviewing resumes, resume critiques, advice from upper year students, that kind of thing. And the co-op department has a number of advisors as well that really help students through the process. But you know, students are responsible for getting their own co-op jobs. But it's a fantastic element of the engineering undergraduate program. All right, we're going to flip over now to admissions, and we have Tony Monroe with us, who will cover off some of the high-level questions that you might have about international admissions today, and some of the hot topic questions that we often get asked. So I will turn things over to Tony.
Thanks, Daniela. Hi, everyone. My name, as Danielle has mentioned, is Tony Monroe, and I'm the manager of international recruitment here at the University of Waterloo. I use the pronouns he and him. So on this slide, you see a sort of a quick comment. We recognize that as students, as graduating high school students, you have gone through tremendous changes over the last couple of years, and there's probably a fair bit of anxiety amongst all of you as to sort of how are the impacts of those changes and what I've experienced going to affect the admissions decisions. And so what we really want you to understand is that Waterloo is an international university, accepts applications, receives applications from around the world, and admits students from around the world. So we are well familiar with the different impacts that the pandemic has caused across countries around the world. And so just know that as you apply to Waterloo, we will consider all applicants equitably and fairly in the context of the current situation, and make sure that all applicants are being assessed fairly and, as I say, equitably. So just so you know that we are well aware of what you're going through. So I'm going to go through sort of the admission requirements, starting here with the admission requirements from our local provincial Ontario curriculum. And what I really want you to highlight, or what I want to highlight to you, is the fact that admission to engineering is really based on a combination of certain required courses. And those are typically your senior most math courses, chemistry, physics, and English. And so in the Ontario curriculum, the grade 12 math curriculum is broken down into two courses, the advanced function course and the calculus and vectors. So both of those are required. Then the senior chemistry course, the senior physics course, and the senior English course are required. Students must have completed those courses. And then what we will do is we will assess your admission average based on your scores in those 5 courses, along with your next highest grade 12, or as you see here on the screen, your 4U or 4M course. And we note here the minimum, but I will talk in a bit about sort of competitive averages that are required to get admission to engineering. As was mentioned earlier by Edmund, there is a question often about, well, how much programming experience do I need, or do I need programming experience to apply to engineering or to be admitted to engineering? And the short answer across the faculty is no, it's not required. The one exception is for applicants to software engineering, who are then required to have demonstrated some programming experience. And there's a number of ways in which they can do that, and it's noted here on the screen, both in terms of courses you might take, or participation in context, or some other related programming related work experience. So with that in mind, as we look at other curriculums, if you are someone who is following the American curriculum, as you see here, those same courses are required. Calculus at the AP level, physics at the AP level, and then algebra or pre-calculus, chemistry, and grade 12 English, and then one other grade 12 academic course. Those 6 averages are what are going to be considered for your admission average to the University of Waterloo in engineering. And again, noted at the bottom is the minimum final grade required in each of those courses, but I'll talk in a minute about competitive averages. And we'll move on to the next curriculum then, which is the IB curriculum. Many of you may be following the IB curriculum. And again, here you see the same combination of math, physics, chemistry, English. It's important to note that when it comes to the mathematics requirement, we require the analysis and approaches, the AA. The AI is not acceptable. And when it comes to the math AA, higher level is recommended, and it's strongly recommended. It's not that we would consider standard level, but because engineering is so competitive, the higher level is definitely recommended. And the same is true of physics. So keep that in mind. And then English A, not English B. And you see there again, minimum final grades of 4 is required in each of those courses for a total of 32. I will talk in a moment about competitive averages for admission. And please note that when we look at IB total or IB points, we do not consider the diploma points. We exclude those from the total score. And then on to, if any of you are following the Indian curriculum, again here, it's the same basic courses at the standard 12, the math, the physics, the chemistry, the English, and then one other standard 12, minimum final grade of 70 in each of those courses. But again, to be competitive, you will need scores much higher than that. I'll highlight those in a second. So please, we'll move on to the next slide. When we look and make our admissions decisions for the Faculty of Engineering, we are not only looking at your academic scores. We will also consider, and an important requirement is that students submit an admission information form. The admission information form is specific to the University of Waterloo. As noted on this slide, it is an absolute requirement for admission consideration and scholarship consideration to the Faculty of Engineering. If you have not completed and submitted an admission information form, or AIF, you will not be considered for admission to the Faculty of Engineering. The AIF is really your opportunity to tell us a little bit about what you do outside of the classroom. So highlight your other experiences outside of the classroom, your motivation, those extracurricular activities, different types of experiences, whether it's paid or volunteer, any other achievements. And there is no single type of experience that is better than others. Tell us what makes you unique and what has shaped your interest in attending the University of Waterloo in engineering. We also have the opportunity for students to complete an online video interview. Now, it's highly recommended. It's optional in terms of admission consideration. So in other words, you don't absolutely have to complete the online video interview, but it will certainly significantly improve the likelihood that you will be admitted. The interview is an absolute requirement for any kind of scholarship consideration. So again, we strongly recommend that students do complete the online video interview. It's a fairly basic interview that consists of 2 questions that, as noted here, generally examine why you want to study engineering and why you might be a good fit for the program you've applied to join. You're given a short amount of time to compose and then record a brief video response. So it's not something that you have to study for. It's not technical in nature. These are very general questions, similar to what you would be asked in a typical co-op interview by an employer. Let's talk a little bit about those probabilities. I talked a little bit about the minimums that would be required for admission, but in order to be competitive and to be more realistic in terms of actually receiving an offer of admission, it's important to note that for applicants to receive an offer, they typically have to have an admission average in the low 90s to mid 90s, and that does vary by program in engineering. There is no general first year in engineering. You're going to be applying to the specific branch of engineering that you are interested in. And as I noted, the AIF does play an important part in the admission decision, and the video interview plays a crucial role in terms of scholarships, but will also be considered from an application perspective. And that no matter what your academic admission average is, that doesn't necessarily guarantee you an offer of admission. In other words, we don't have a set cut line. When you look at the probability of receiving an offer of admission to the University of Waterloo, for biomedical and software engineering, they are our 2 most competitive programs. And so what you should note here is that even with a an admission average of 95 or higher, there is still just a 33% probability that you will get an offer of admission. And if you're below 95, you see that that probability in biomedical and software drops down significantly. In computer, electrical, mechanical, mechatronics, and systems design, about a 70% probability of getting an offer if you have an average admission average above 95, and then again drops off once it's below. And you see that once you're below 90, there is a very, very small probability that you would get an offer in one of those programs. Architectural, chemical, civil, environmental, geological, management, and nanotechnology, still a very high probability that you will get an offer if you have an average above 95, but then again drops off significantly when you get below 90. So you really do need to have averages in the low to mid 90s to be competitive. And on the right side, you see just a sense of how competitive the programs in engineering are, with over 14,000 applicants a year to engineering, of which roughly 4,000 receive an offer of admission. Typically, about half of those students will accept their offer of admission, and that ends up with us having an entry first-year class across all engineering of about 1,800 students. A bit in terms of the timing, the applications have opened now and will continue right up until the 1st of February, at which point the application closes, the application window closes. For the Faculty of Engineering, they make 2 rounds of offers, one towards the end of March, and then the final round, and therefore all offers will be out by the middle of May. In some individual cases, there will be some admissions decisions made on a case-by-case basis, but you should be aware of the fact that when you apply to Waterloo for engineering, it is most likely that you will only hear about a decision in the early part of May. There is a relatively small number of decisions that are made towards the end of March, early April. We often get questions about the possibility of transfer credits. Please note that for students who are taking either the IB or the AP systems, in engineering, we do not accept any of those courses for transfer credits because the professional engineering licensing or accreditation that our Faculty of Engineering has requires that all courses must be completed at a post-secondary level. So please take note of that. It is important that if you are completing the IB or the AP, you should inform us of that as part of your AIF. It does help for us to know that as part of the AIF. Another hot topic that comes up often is the question of choice. When you apply through the Ontario University Application Centre, you can choose up to 3 programs as part of the standard application, and Waterloo Engineering does not give admission preference to first choice applicants. So it does not matter whether you list an engineering program as your first, second, or third choice on your OUAC application. All applications to the University of Waterloo in engineering will be treated equally and the same. It's also important to note that, as I pointed out, Waterloo Engineering is a direct entry program. In other words, you would be applying to specifically, for instance, electrical engineering as opposed to mechatronics engineering or civil engineering. That means that the program itself, each of the programs offers somewhat less flexibility than in the general first-year program. And therefore, transferring from one engineering to another may not be possible. There are some programs that are close and similar, but in most cases, you should apply to the specific branch of engineering that you are interested in graduating from. You shouldn't be considering applying to one in the hopes that you will be able to transfer to another, because it probably is unlikely that that's possible. As noted here, transfer approval depends on a number of factors, including the space availability, your good academic standing, and evidence that you might be a good fit for the new program. So I wouldn't apply to one branch of engineering with the intention of eventually transferring to another. And the impact of transferring is that you may be required to return or repeat some courses in your first year, therefore delaying your graduation by up to a year or more. Another question we often get is the question related to repeated courses. So in some cases, students just choose to repeat a course because they feel that they can obtain a higher grade by taking the course a second time. The stance at the University of Waterloo in the Faculty of Engineering is that repeating a required course is only recommended if your grade in that required course is below that minimum threshold of 70%. Unless a suitable explanation is provided, the applicant's admission averages will be adjusted as noted on the screen. If the original grade was 70% or higher, we essentially will use the original grade. So even if you got a significantly higher grade the second time around, we will not consider that higher grade. We will look at the first grade if it was 70% or higher. If the original grade was below 70%, we will immediately deduct 5% from your overall admission average, not just from the average in that particular course, but from your overall admission average. So it's a significant impact. You know, I would suggest not repeating courses. It is not to your advantage for admission to the Faculty of Engineering. And please note that if you have repeated a required course, that makes you ineligible for entrance scholarships to the Faculty of Engineering. And then the question now with the current structure of high school curriculum, in some cases, some students are going to have to or will have chosen to take a required course in the 4th quadmester of grade 12. It is our normal practice to use a combination of final grade 11 and in progress or final grade 12 marks when we calculate your mid-year average. If a required course is taken in the 4th quadmester, we will not receive those marks in time to use when calculating your admission average. So we will instead review the marks achieved in the related grade 11 and grade 12 subjects when making an admissions decision. I hope that's clear. For those of you who are required to submit an English language test score, we do have an English language pathway to the University of Waterloo. The first one is our I-BASE program, or our Intensive Bridge to Academic Success in English, which is available to all Waterloo engineering programs except for architecture. When you apply to engineering, if your English language test scores fall slightly below our minimum admission requirements for English language proficiency, then you could potentially be given an offer into our I-BASE program. And the I-BASE program is a 7-week program that runs immediately prior to the start of the fall semester. So the 7 weeks prior to the beginning of September, you would go through the I-BASE, and assuming successful completion of that I-BASE program, you will then transition immediately into first year studies in the fall. The other option is our BASE program, Bridge to Academic Success in English, which is available again for all engineering programs except architecture. This is a different program. This is for individuals whose then English language proficiency scores are a bit lower than our minimum, significantly lower than our minimum admission requirements, but their academic courses are strong. Those students are then provided the opportunity to complete the 8-month BASE program. Starting in the fall, they would complete 2 semesters of an intensive English language program. And upon successful completion of those 2 semesters in the BASE program, would then transition into full-time first-year degree studies the following September. So as you see here, if you're admitted to BASE in the fall of 2022, then you move on to first years in fall of 2023. And then in terms of ESL courses, admissions requests an English language proficiency test score for any engineering applicant who is enrolled in an ESL, or English as a second language course, in the 2 years prior to the requested start at Waterloo. For fall 2022 applicants, enrollment in any ESL or ELD course in fall 2019 or later will trigger a proficiency test requirement. And those applicants will be emailed in February to request the submission of test scores. if they have not already been submitted. So if you know you need to submit an English language test score, then we encourage you to complete that test and submit that score as soon as you can. If you're uncertain, wait and see if you are emailed in February, and then you will be required to submit a test score at that point.
Excellent. Thank you so much, Tony. That was fantastic. And I think we covered off a lot of really key information there. So we really appreciate your time today. Just up here on the screen now are a number of other webinars and virtual events that will be happening soon over the next couple of months. You can scan that QR code there or visit our website for more information about those. All right, so I think we're going to go ahead and get into our panel discussion now. We've got a few minutes left. So I would like to ask our panelists to please go ahead and turn on your cameras. I think we've got a few questions that have come in already. And for the attendees, if you do have any questions, feel free to submit those through the Q&A button at the bottom of your screen. All right, so I'm going to start off with a question for Cliff. Do we still have Cliff on from MME? Cliff, can you turn on your video? Awesome.
Yeah.
All right. So we had a very specific question, actually. As an undergrad student in mechatronics, could they take part in research projects at Avril? Is that allowed, or how does that work?
Oh, yeah, I'm not working in autonomous, but just speaking of how the department works, yes, yeah, for sure. So I mean, like if there's co-op positions in Avril, you could go that route. There's the undergraduate research assistants, which I hire a lot of them in my lab. So that I think it's 6 hours a week. You get paid a small stipend, but you can it's almost like a volunteer, but just get experience. And for sure, that'd be a good way of getting your foot in the door there too. So,
Okay, excellent.
Short answer is yes.
Okay, that's awesome. And Cliff, another quick question for you while we have you up. What are the key differences between mechatronics engineering and robotics engineering? We don't offer robotics engineering at Waterloo, but perhaps other universities do. Can you comment on what the differences or similarities would be from your perspective?
That's a good question. Again, I'm on the solid mechanics side, so I'm speculating a little bit. So I don't know specifically the difference between mechatronics and robotics. I know that we have an emphasis on robotics. We have the Robo Hub. We have I guess I can't comment. Sorry. I think they're probably pretty close if you look at the mechatronics facilities and the courses. I think it's probably the same, but.
Yeah, I think that's correct. We would definitely recommend someone interested in robotics to really consider looking at mechatronics engineering as a good viable option. So that's great. Thank you, Cliff. Tony, I have a question for you. How can students find out more about the fee structure as international students? What would they do in order to find out about that?
Thanks, Daniela. Great question. So on our main admissions webpage, which is uwaterloo.ca/future students, and I'll type it into the chat after I'm done answering. They will see on there that there is a page specifically about finances where they can see information about our tuition, about scholarships, and there's also a really helpful student calculator, budget calculator on there. So students can use that to really get a pretty good sense of what it's going to cost to study at Waterloo for 1 year or 2 semesters, which is essentially 8 months. I see there that Erica has put it into the chat. Thanks very much, Erica, for doing that. So that's probably the best way that students can see what their costs are going to be, because tuition is only one part of it. There's also obviously your living expenses during that year that are important to factor.
Okay, thank you, Tony. That's fantastic. Okay, I'm going to go over to Nicole now, and maybe David or Shana would like to chime in on this one as well. But Nicole, could you explain a little bit more the difference between doing a program at the School of Architecture versus architectural engineering, and why a student might choose one program over the other?
Yeah, absolutely. Thanks, Daniela. So the Bachelor of Architectural Studies program, it leads students into becoming a professional architect. That's what it's setting the framework for. The architectural engineering program is actually a little bit closer to civil engineering in curriculum, and it is setting up students to become engineers. Both programs study design, both have a cross-disciplinary approach to design involving critical thinking and cultural and global perspectives. Largely, it's just the end point that students want, whether you want to focus more on engineering or whether you want to become an architect.
Awesome. And maybe a question then for Shayna and David. Did you consider architecture over architectural engineering, and what sort of led you into architectural engineering? Shayna, let's start out with you.
Yes, actually I did want to become an architect, and I went to Carleton. I realized that architectural engineering and becoming an architect were completely different. A lot of people think it's similar, but a lot of people don't know about it. Actually, I think, as already mentioned before, architecture is more focused into designing, where architectural engineering is more towards the structural side and less of the design. We do have designing, but we focus sort of into, it's like a bridging of civil engineering and architecture. So we have all like structural analysis to do, a lot of math and stuff to do. I feel like I remember first year doing just plain architecture was more towards designing and learning the materials and stuff. I think that's the main difference.
Okay, that's great, Shayna. Thank you. And I have a question now, maybe for Adnan and Jason. Could you tell us a little bit more about the co-op experiences that you've had in your respective programs? So Jason, maybe we could start off with you. If you could explain a bit about some of the co-op jobs that you've had, please.
Yeah, sure. I've had 6 co-ops so far. A couple of them have been for consulting engineering companies around Waterloo. One was doing some field work, while the other was more of an office job with Hatch in Mississauga. I've also had a couple co-ops for the university. One was doing research for a professor in civil engineering, and the other was actually as a TA for one term. And then my most recent co-op was actually with a software company in Toronto that makes geotechnical software.
Okay, did you have a favorite co-op term of the ones you've had?
Maybe my last one. It's nice seeing like all the things you learn in school kind of pay off and be applied in the workforce. So that one was probably the most applied co-op in terms of my knowledge. So that was nice.
Okay, awesome. And Adnan, could you tell us a little bit more about some of the co-op jobs that you've had?
For sure. So my first co-op term was actually with a professor from chemical engineering, Professor Simon. And I did research for him on his 3D printing project. And it was basically concerned with finding a new material to be used for car cushioning seats. So it was with Ford Motors as well. And then from there, most of my co-ops have been with the university, because it was when the midst of the pandemic was hitting and it was a bit tough to find a job in the industry, especially for nanotechnology. At that time, it was the market was a bit restricted in terms of how many available jobs were there remote to be able to do remotely. So I had to do some more co-ops with the university, and I stuck with the CHE faculty, and I did co-ops in terms of data. I did data collection. I also went into the CHE labs and helped with some safety standardization practices that they had to be done. And I was working with Professor Jason Grove, so he was very good in helping me understand how the faculties work and get a better understanding. And now I'm actually going into my 5th co-op term, and I actually just got a job at a company here in Elora that they make polymers. So pretty excited about that. It's more material testing and data collection, which is the field that I feel most comfortable in nanotechnology, especially with the great relation to material science and materials engineering. So most of my co-ops have been fun, definitely fun. A lot of experience that I've gotten from them, made some really great connections. And my favorite one would probably be just my last one, because I was able to do a lot of remote work, but also go a lot on campus campus when that was something that was a bit rare to go on campus. So it was definitely my favorite co-op term, and hopefully to the other ones that come.
Fantastic. Thank you so much. Ada, we have a question for you now about management engineering. Are you able to unmute yourself there? Yes. Wonderful. Great. How much programming is involved in management engineering?
Excellent question. Yeah, we get this question all the time. So I did mention that information systems and software is one of the core areas of management engineering. And so I think I looked at other programs carefully once, and I noticed that I think management engineering has one of the largest numbers of programming courses in engineering within the 14 programs. So there are quite a few computer programming courses starting in your 1B term, and then every term after that, it sort of builds on it and kind of branches off. But however, I want to mention that, well, two things. First of all, we don't expect students to have any programming experience. So we really assume no programming knowledge when students are admitted to the program. And I think we find that a lot of students had no programming experience, didn't know if they would like it or anything like that. And they find that, because we assume that you don't know anything when you start, even those who have no programming experience can definitely learn and then actually learn to enjoy it and become proficient at it. The other thing I want to mention is that although programming is an important part of the program, and some students really thrive in it and are able to get certain jobs in sort of a software industry, there are also quite a few that don't necessarily, it's not really that's not why they want to be in management engineering. And so they're able to succeed in their courses, but they will definitely get jobs that require no programming. Having that knowledge about how programming works is important in order to work with, say, for example, software engineers in their organizations and to be able to talk to them and translate, for example, customer requirements into software requirements. So that's very important, but they don't necessarily do software development, computer programming in their jobs after graduation. So really all sort of breadth of pathways are possible. I hope that answers the questions.
Okay, no, thank you, Ada. That was fantastic. Moving over to Edmund now, we've got a question about ECE and your program. How many hours a week would you say that the average ECE student spends on coursework? And maybe between lectures, your homework, etc. How much time a week are you spending actually working as a computer engineering or electrical engineering student?
This does depend on your abilities as a student, of course, but for our specific program, computer engineering, I do believe it's an average of around 40, so similar to that of a full-time job. The program is a difficult program. That's why you need to spend these hours studying, going to lectures. You will have time to, take breaks, have fun, but you have to make sure that you're also allocating that time to study, right? Don't make sure that if you are having fun, you're taking a break, you have accomplished what you've done for what you want to be done for the day. And it's really just about time management. But yeah, it's definitely a hard program that you will need a lot of, you'll spend a lot of time on for school, but if you have good time management, then you should be fine.
Excellent. Thank you so much, Edmund. Andrea, I have a question for you now about co-ops for systems design engineering and biomedical engineering students. Could you give some examples of co-op jobs that students in systems or biomedical sometimes get?
Sure, that's a great question. So systems engineering students get a variety of co-op positions. Often, a lot of them are in software kind of areas. So for example, sometimes they'll get recruited by some of those bigger companies like Facebook or Google or things like that. Sometimes they'll work, I know some of them have worked with Tesla, for example, and also often for smaller startups, for example, renewable energy or those kinds of solar panels and just sort of pulling a bunch of things that I've talked to different students about. So really a really wide variety. And similar to, I think, something that someone said earlier about, mechatronics versus mechanical. I mean, students can kind of steer themselves a little bit in the co-op process to, apply for jobs that they're really interested in. So for example, if they feel like, I've done 3 sort of product development jobs and I really want to try something new, then they can, they can apply for that job. And if they can sell themselves in the interview, then they can make that transition. So, I mean, I think that's a really good thing about co-op. By the biomedical engineering program, again, there are some software jobs, not as many as for systems. More students there would get positions, for example, in hospitals or working in the healthcare industry more directly. So.
Okay, fantastic. Thank you so much, Andrea. I think we're going to wrap up soon. I know we're a little bit over time. I maybe would like to give Tony one last opportunity just to share any final advice on the admissions process side of things for our international student audience. And maybe just, if you've got any tips for anything that our international students should be doing at this point in the application cycle, that might be helpful. And I will just add that we have a number of other webinars coming up as well that will hopefully help answer additional questions and provide some admissions advice for engineering programs. But I'll turn it over to you, Tony, if you've got any last words of advice for our international student audience.
Well, thanks, Danielle. I guess what I would say is, first and foremost, make sure that you have the required courses that I noted. So, the chemistry, the physics, the math, the English, because those you have to have, and do focus on getting the best, the highest possible grades you can in those courses. That 6th course can be anything. The other thing to be aware of is the importance of the admission information form. And so there, as I tried to point out, there's no single answer as to sort of what's the best kind of extracurricular involvement or engagement. There is no single answer to that. It's really your chance to tell us why you are particularly motivated to study engineering and what things you've been involved with, whether that's work related, whether that's a cultural group, a sports related, anything in your community that is particularly your passion that you've focused and been involved in, then that's really the basis for the admission information form. And then the online interview, don't sort of think, well, it's not required, so I won't bother. No, it's in your best interest to complete the online interview. It's very straightforward. It's 2 questions. There's no technical requirement or training. It's really just your chance, again, to show us that you are motivated and that you can communicate that motivation effectively. So.
Fantastic. Thank you so much, Tony. And I'd like to thank all of our panelists again today for being here with us and sharing more about the engineering programs that you were representing. And thank you to our attendees for being here today. We really appreciate your time, and we would encourage you to check out some of our other webinars. We've shared a link there in the chat, so please do check out those other webinars that we have coming up, and we hope to see you all soon. Thank you so much, everyone, and have a great day. Take care.